Imagine a winter holiday in the mountains of Sikkim. We're visiting Pema and Polden, two students spending the break with their grandfather. On a global scale, the sun is our main source of heat. But to understand our daily lives, we have to look at how that heat actually moves around us here on Earth. Indoors, their grandmother is cooking a traditional noodle dish called thukpa in a large metal pan over an open fire. Why is that pan made specifically of metal? The answer lies in the first of three ways that heat travels. Metals are what we call good conductors. This means they allow heat to pass through them with very little resistance. This process is conduction, the way heat moves from the hotter part of a solid object to the colder part. Think of it like a relay race. When a particle gets heated, it vibrates, passing energy to its neighbor. Even though heat travels, the particles themselves do not move from their positions. They are locked in place. Materials like wood, glass, and clay are different. They don't pass heat easily, so we call them poor conductors, or insulators. This is why clay cups keep tea hot longer, why woolen clothes trap air to keep us warm, and why traditional houses in the mountains use mud walls to prevent heat loss. Conduction is the primary way heat travels through solid objects, making everything from cooking to staying warm in a cold house possible. Now, look at the smoke rising from the burning firewood. This movement introduces the second way heat moves. When a gas or liquid warms up, it expands and becomes lighter. Because it's lighter than the surrounding air, it's forced upward. As that hot air rises upward, cooler, heavier air rushes down to take its place. This creates a continuous loop. This cycle is called convection. Unlike conduction, the particles here actually move from one place to another to carry the heat. This happens on a massive scale. During the day, hot air rises off the land, and cool air rushes in from the ocean. This creates the sea breeze felt by people living near the coast. Convection is how heat moves through liquids and gases, using the motion of the particles themselves to distribute energy. Even if the children don't touch the pan or sit directly above the rising smoke, they still feel the fire's warmth on their skin. This is radiation, where heat travels directly outward from a hot object in all directions. Radiation is unique because it does not need a medium, like a solid, liquid, or gas, to travel. It can move through completely empty space. We adjust to this by wearing light colors in summer to reflect radiation and dark colors in winter to absorb it. This process is what allows heat from the sun to travel through the vacuum of space to reach our planet. In the Himalayas, a traditional room heater called a bukhari uses all three of these methods at once. Conduction heats the flat iron top of the stove, which provides a surface for cooking. Convection carries the hot smoke up and out through a long chimney pipe. And the hot iron body of the stove warms the room through radiation, beaming heat directly to anyone sitting nearby. By observing these processes, we can design tools that help us live comfortably in extreme environments. These same principles drive the water cycle, where radiation melts mountain snow into the water that sustains communities. To recap, conduction moves heat through solids while particles stay in place. Convection moves heat through liquids and gases by sending warm particles upward. And radiation moves heat through empty space without needing any material at all. Whether it's a hot cup of tea or a breeze from the sea, we can trace each sensation back to these three ways that energy moves through our world.